Welcome to MyProjectBazaar.com. Now we discuss about the product for a low latency and low power hybrid scheme for on-chip networks. Next we see the abstract for the product. With the rapid development of advanced nanometer IC technology continuously shrinking transistor dimensions allow designer to integrate the increasing number of processor or IP codes into the single silicon chip. Traditional bus-based processor communication is no longer suitable due to the poor scalability. Instead of network on chip has emerged as a scale and promising solution of global communication with large multi-core systems. Typically example for 48-core SEC processor and the 64-core Tile 64 microprocessor and the 80-core teraflops research chip. All these examples exploit to packet switched NOC, which brings advantage of high flexibility and high bandwidth to communications. However, the such merit is achieved by exploiting a complex route pipelined. This pipelined stage of a baseline packet switching router include the buffer wire stage, the router computation RC stage, the virtual channel allocation stage, and the switch allocation stage and the switch transfer stage. On the one hand, the complex router pipeline leads to high latency ratio, although the likelihood routing and aggressive speculation shorten the critical path through the router stage. The packet switching router still occupies the higher ratio of communication latency when compared with one cycle link delay in a mesh connected NOC. On the other hand, the complex router pipeline lead to the higher power ratio. NOC architecture has emerged as a visual factor that determines the performance of power consumption of many core systems. This paper proposes a hybrid scheme for NOC which aims to obtain the low latency and low power consumption. In this presented hybrid scheme, a novel switching mechanism called virtual circuit switching is proposed to intermingle with circuit switching and packet switching. While traveling, the virtual circuit switching can transfers the router based on the virtual circuit switching connections are allowed to share the common physical channel. Moreover, the path allocation algorithm is proposed in this paper to determine the virtual circuit switching connections and the circuit switching connection on the mesh connected NOC, such as the both communication latency and power are optimized. A set of synthetic and real traffic workload are exploited to evaluate the effectiveness of the proposed hybrid scheme. The experimental results show that our proposed hybrid scheme can efficiently reduce the communication latency and power. For instance, for real traffic workload, an average low latency reduction and power saving can be obtained compared with the baseline NOC architecture design. Next we see the flow diagram for the product. The source router input 8-bit data to be applied for the mesh topology based NOC architecture design. This design consists of 16 router. This router consists of each single router architecture design based process for our overall 4x4 NOC architecture and to apply the mesh topology connection for 4x4 router architecture designs. This single router to be consist for the master and slave based router memory and the network interface and the switch and selection logic. This logic to be designed by the single router architecture design and to process the neighbor node estimation for overall router conditions. One of the source node to be allocated for the each and 2 or 3 neighbor nodes. These neighbor nodes to be allocated for the next data transmission based process. So we obtain the packet switching, circuit switching, virtual circuit switching based weighted calculation data bits and to process each and every router position considers some data bits and we analyze the data bits and to calculate the minimum distance value based on virtual circuit switching. Then to calculate the overall minimum distance value and to analyze shortest minimum values for overall 3 nodes and the S condition to be satisfied. If the condition is no, this shortest path allocation process to be processed next path selection, next router estimation process, and finally we identify the next shortest path, next neighbor router estimation control, and this control to be followed by overall destination based final data router approach, and we identify the next router estimation based process and to calculate the final destination router design. This process overall to be identify the shortest path allocation for our 4x4 NOC architecture design. This is our the overall flow diagram for the 4x4 mesh topology based NOC architecture design. Finally, we see the output for the product. This is our the Xilinx ISC project for our mesh topology based NOC architecture design. Our process was developed in the VHDL language and our project was doing the Xilinx 14.2 software. Finally, we open the ISC project navigator file. This is our the overall main design for our overall architecture. Then to select the simulator process, this simulator process to simulate the our overall mesh topology based NOC architecture design. This process was completed successfully, and to open the ISM project navigator. This navigator is used to simulate the our overall NOC architecture design. Then to open the reset function, this reset function to be applied for the once for initial position, and to apply the data for any other 8-bit input data bits for our required NOC architecture data bit. Then to apply the one conditions for data write positions. Then to run. Then to apply the 0 level for overall architecture. Then to run. Initially run the and finally we get the output for our overall architecture design. This is the shortest path identification for overall architecture. This is our the final data bits for identification process. This is the shortest path location for our final NOC design. This is the shortest path designs for our P0 router and the path 5 router and the path 10 router, and to finally get the output data router. This is the final data output router for our the simulation based process for overall mesh topology based NOC architecture design. And the implementation design. The implementation design to view the RTL schematic for our required architecture. This RTL diagram to represent see what are the logical block presented in overall NOC architecture design, and the technology diagram to represent see what are the input output pins, lookup table, and the buffer connections and the flip-flop pairs to be presented in overall NOC architecture design. These are the lookup table structure for our final NOC architecture. These are the circuit complexity for our NOC based process, and to calculate the timing summary also. This is our the synthesis report for final data bits. This data bits to represent the timing summary for overall NOC architecture designs.